All right, I'll go ahead and introduce our next speaker, Dr. Daniel Linhares. He earned his veterinary degree in 2003 from the Universidad Federal de Goiás and an MBA in 2007 from Fundação Getúlio Vargas in Brazil. In 2013, he completed a PhD in veterinary population medicine at the University of Minnesota, where the focus of his research was on evaluation of immune management strategies to control and eliminate PRRS virus. Dr. Linhares gained extensive experience in swine production medicine while serving as a herd veterinarian and production manager for Agroceres PIC from 2003 to 2009. After completing his PhD at the University of Minnesota, he returned to Brazil and served as Technical Services and Health Assurance Manager for Agroceres PIC. Dr. Linhares' primary responsibilities at Iowa State University are in clinical research and outreach, and he also contributes to teaching in the veterinary and graduate curriculum. And his talk today is entitled New Surveillance Methods to Detect PRRS at Low Prevalence.
All right, thank you. Good afternoon, everyone, and hope you are enjoying the great Iowa Swine Day. Thanks for sticking till the end. Looking forward to the barbecue. I understand that I'm between you and the barbecue, so I will keep you guys on time. And so appreciate the opportunity, appreciate the invite from Drs. Jason Ross and John Patience to talk with you here today about surveillance methods to detect PRRS virus at low prevalence, specifically talking about breeding sow farms. So the results or studies, the projects we're going to talk about is a summary of some of what our team of graduate students are currently doing. We have a number of projects going on, and they're all focused on evaluation of strategies to prevent, detect, or manage swine infectious diseases. They're all studies are under field conditions, and right now here, in the next half hour or so, we're going to talk about the detection part, which is the monitoring aspect, and focusing on studies specifically with PRRS virus. So talk a little bit about population-based monitoring systems as opposed to individual pig-based monitoring system. We're going to talk specifically about breeding herd, as I said, different methods to detect the virus at breeding herds. And then moving on, we are going to talk about using veterinary diagnostic laboratory data to understand what's going on in the swine industry or specific states level. And then we're going to summarize the findings. So the swine industry has increasingly been moving from, moving from, but using more population-based sample relative to individual pig sampling, right? Individual pig sampling being defined as getting or holding individual pig one at a time for collecting serum, blood swab, tonsil scraping, whatever individual-based sampling protocol. Moving from this, or in addition to this, the swine industry has been increasingly more using the population-based sampling. Think about oral fluids. We're going to talk a little bit about oral fluids here today. Also processing fluids and other sampling methods. Idea being that those population-based sampling, they are more practical, they are cheaper, and studies shown that they have higher herd sensitivity to detect the virus at the population level. So if you're not interested in a specific individual, a specific pig, why not collecting those population-based samples, which are more practical and more reliable, cheaper to define disease status at the whole population level. So that's what we're calling the monitoring surveillance systems 2.0. They're based on population-based samples. We're going to come back to this slide after we talk about the different methods. And there is no single method that we believe it's the best. It's, of course, the best method depends on what's your question. So you would mix and match those new population-based sampling to address your specific question. And we're going to talk about some of those questions during the presentation. So here just some pictures to illustrate what we mean when we talk about processing fluids, right? Processing fluids being the fluids collected at the day of piglet processing. So the day that you're tail docking, castrating the pigs, you collect those testicles and tails in a bucket, right? And the bucket, which is you have a clean disposable plastic bag here in the bucket to make the collection, to avoid cross-contamination between collections. And you put a cheesecloth or any other restraining method here, because the idea is that the testicles and the tails, or the nuts and tails, so the fluid coming from those is going to drip to at the bottom of the bucket, and you collect that fluid. That's the fluid that you use for disease detection, antibody-based or DNA, RNA, PCR-based methods, right? So this is a very useful tool to collect or to sample pigs at that processing age time, 3, 4, 5 days of age. As pigs grow older and before they're weaned, you still want to know what's the disease status of these piglets just prior to wean, or when they're due to wean, and that's when we are exploring the family oral fluids. Family oral fluids being defined as you hang a rope where not only the baby piglets but also mom, right, the sow, the whole family has access to the rope. They chew the rope, they leave the oral fluids, and we use that fluid to submit for diagnostic testing. So processing fluids, 3, 4, 5 days of age. Family oral fluids, due to wean, around 21 days of age or more. And in addition to that, we're going to talk briefly about using production records to detect disease outbreaks, right? Especially if you're talking about diseases such as PRRS and as PED, where you expect a big change in productivity levels following outbreak. Why not using selected production parameters such as number of aborts, number of pigs that number of pig lost, number of sows that are off feed. If you monitor those numbers and if you keep track of those, and you can take advantage of tools like a SPC or statistical process control to identify when there is a change in the expected number of aborts or preweaning mortality or other parameters. So we're working with some herds to collect those numbers on a daily basis, some within a weekly basis, to identify in an automated fashion some triggers of when something is going wrong in terms of numbers, and when farm should employ some extra monitoring, diagnostic monitoring method to better understand what's going on. And we're not going to talk about the abattoir surveillance, but also has some studies where collecting oral fluids at the abattoir, at the slaughter plant, to monitor disease status of piglets, of pigs or finishing pigs. But we're going to focus on the breeding herd today. So processing fluids. I'm going to focus here today not on the specifics about validation of the processing fluids. We're going to talk more about the application of this sample type for disease detection, for PRRS detection. So processing fluids, something that's still relatively new. Last year, a year ago, there were very few people talked about processing fluids, and today, looking at the VDL data, veterinary diagnostic data, we observe that about 5 to 7% of all samples that are submitted to the lab for PRRS detection by PCR, it's processing fluids. So it's definitely a sample type that's new, but it's being picked up because, again, it's practical, it's easy, results make sense, it's very sensitive, so people are picking that up. So the good about processing fluid, high sensitivity at the whole room level. So again, if you're not really, if it's not really important to understand what's the disease status of a specific pig or a specific litter, if you really want to know what's the status of the whole farrowing room, so why not using processing fluids? That's what it is for. It's easy, practical, it's picking up, and we have a number of studies where we not only want to detect the virus, but want to do some further molecular analysis and understand what kind of virus we have. So processing fluid is a good sample to sequence the PRRS virus too. And also we are exploring that to do some antibody testing as well, detecting IgA, IgM, IgG, some other types of antibodies for PRRS. The caution, so it's a very good sample type being picked up, as I said. The caution is that processing fluid, you collect them from 3, 4, 5 days, pigs of 3, 4, 5 days of age. That reflects disease status at that point in time, not necessarily the disease status of weaned pigs, right? So it may not reflect the due to weaned piglet status. Still need to sample those pigs with a different sample type. We're going to talk about that in a bit. And because it's more sensitive than collecting 30 or 60 or even 90 pigs per month, right? Processing fluids, you have the potential to sample pretty much all the pigs that are being processed at a given week. Your coverage is much better, it's much wider, so it's more sensitive. That means you are detecting the virus longer time. When in an individual-based sampling, it's very common to work with 30 or 60 pigs, right? And 30 pigs has the potential, if you do the math, to detect disease at 10% level. If you raise that to 60, you can detect disease at 5% prevalence level, right? And with processing fluids, you detect that pretty much at near zero prevalence. So the time, it is expected that the time for a herd to become negative with processing fluid time is longer, just because you are being able to detect the virus at much lower prevalence. And in processing fluid, it's really not a sample designed to collect at a later level. It really works best if you work at a whole farrowing room level. Here, data from about 25 herds after they got infected with PRRS and after they implemented load, a herd closure, and a whole herd exposure or load close expose program, how long it took to reach 3 consecutive negative weekly PCRs on processing fluid testing. And so here you have the proportion of herds that obtained that 3rd consecutive negative weekly PCR over time. And what the plot shows basically here is that if you draw a line here in the 50%, or the median time to reach negative was about 28 weeks, with 25th to 75th percentile between 26 and 31 weeks, so not a lot of variation. The catch here is that pretty much all those herds here, they were implementing batch farrowing system. And if you had the chance to watch Dr. Clayton Johnson's presentation earlier today, he talked just about that, about using batch farrowing system to shorten time to produce negative pigs, to move the virus, to better control viral and bacterial diseases in the population. So another piece of data here before we move forward to other sample type. I have 2 farms here, Farm A, Farm B. This data is from Dr. Grant Allison, who was kind enough to share that with us. And this is a pre-weaning piglet PCR test for PRRS. The question is, which farm is PRRS stable? Green means the negative, the diagnostic results were negative. Red means diagnostic results positive. They're both 10 months, monitoring over 10 months of time. Right here, consistently negative, and here we have some positives over time, intermittent detection of PRRS here over time. The thing here is that those are the same farm. The difference is that here they were testing 30 winners in pools of 5. So that's the current AASV, American Association of Swine Veterinarians, guidelines for PRRS testing. You test 30 piglets per month, right? And keep testing until you get 4 weeks of consecutive results over time, and you call that as stable. That's the current definition for PRRS today. And this farm would be declared stable over here and kept stable for the rest of the next 5 months. But then the same farm kept testing processing fluids on a weekly basis here, 2 processing fluids per room, and you see how much more sensitive processing fluid was, right? If all you were doing is testing 30 do-to-win piglets, you'll never find the virus up to this point here. Another piece of data that's from Dr. Paul Yeski, where he presented that at AASV, where he got each line here is, so he was collecting processing fluids on a daily basis in a herd, and then he was pooling, so he was collecting processing fluids on a daily basis, so up to 5 processing fluids per week, and then submitted to the VDL to test those, right, in an individual basis, but also he also pooled the daily samples in a week to test one sample per week. And what he observed here is that every time that you had, so those are the results, the PCR results. Red means tested positive, green means tested negative. What he observed is that every time there was at least one positive day, the week pool also tested positive, showing that processing fluid, it's pretty much it's a good idea to save those funds. And even though you collect every day and you collect processing fluids, you have a daily representation of pretty much all the piglets that were processed in the farm that week, and you test just with one PCR. So it's a very good deal, right? One PCR would reflect the status of pretty much all the piglets that were born that week. That's very, very powerful monitoring system. And even if you think about that, even better, if you think about that, you don't have to be there every day. On-farm personnel, they are collecting processing fluid regularly. All you ask is to change that bucket between farrowing room, between days. So it's pretty powerful to think that we can now sample all the piglets that are being processed with a single PCR, and you do that on a weekly basis. It's 4 or 5 PCRs per month. That's much less than what we were doing before with the 30 piglets per month, with a better chance to detect the virus. So Acknowledgement for Processing Fluid Studies had proposed, those were grants that were funded by Zoetis, National Pork Board, IDEX, great help from the ISU Veterinary Diagnostic Lab team, and collaborated without help from those folks from the field. Some of them, Dr. Clayton Johnson, Dr. Paul Yeski, Dr. Emily Byers, Rebecca Robbins, Matt Turner, and others. So as I said, processing fluids, very good method to detect the virus at 3, 4, 5 days of age. We still need to understand what's going on in the do-to-win piglet population, right? And so why not using ropes to collect fluids from those piglets that are just about to be weaned? And we tried several things to obtain oral fluids from this age group. We tried different times of the day, different flavors, different combinations of SOPs. It's not consistent to obtain the success rate to obtain oral fluids from those folks. It's not good until you try family oral fluids. So the family oral fluids, again, when you hang the rope, where not only the baby piglets here, the weaners, but also the sow has access to that. It's pretty straightforward to collect oral fluid from from those, and we're calling that as a family oral fluid, because it does have the influence from mom here. So the next question is, all right, we can obtain that fluid, it's family oral fluid, it's not from baby piglets, not from mom, it's from both. So how good is that to detect the virus at that age group? So Marcelo went out there in 72 matching sets. He collected blood samples from all the piglets in the litter and collected the family fluids, right? And here we have 3 rooms here. Let's focus on this one here for example. Each rectangle is a litter. Each little box here is a pig. Red means tested positive by PCR. Blue means tested negative by PCR. And the line here represents the family oral fluid result. So this crate here had the family oral fluid testing positive by PCR, and this one here had negative by PCR. We're going to summarize this in a little bit, but before, I'd like to stress a couple of things here. Observe that in this farrowing room here, where you had 13 piglets positive in the room, those 13 were not randomly distributed. Those were kind of clustered in a few litters in a corner here. So the assumption that the disease is randomly distributed, at least in this data set here and in others that that are reported from the literature, that's not right. So that must be taken into account when you design sampling methods. So one way to summarize that is looking here, what's the probability to detect the virus, PRRS virus, by PCR in family oral fluid, as a function here of number of piglets individual piglets that were positive in the litter. And what he observed was that when there was no piglet positive in the litter, there was no family oral fluid testing positive, showing here specificity of 100%, no false positive. When there was only 1 or 2 piglets in the litter, there was a 50% chance that the family oral fluid will also test positive. And in those situations where you had 3 or more piglets, viremic piglets or piglets positive by PCR, by serum PCR, family oral fluid were positive all the time. And so that brings us to this question, how many oral fluids do I need, right, to detect the virus at low prevalence? We're still working on future studies to better understand get more data on this very low prevalence. In Marcelo's data, we have data about here in this low but not near zero prevalence. But anyways, we understand that to collecting the individual, if you're using the individual piglets to detect the virus under this situation, you're talking about a sample size, unpractical, and hard to think that people are gonna start bleeding a couple hundred piglets every week. So just a quick exercise here, work in progress on some simulation-based studies that we're doing with the data that we currently have, that I just showed you. I'm gonna skip this to make it simple. And so if you hang 10 family oral fluids and test them by PCR, and if they are all negative, data from Marcelo here so far shows that that there's a lot of evidence that the disease, if it's there, it's gonna be under 2%. That's why we still more data to understand better this scenario here. But again, if you show with the data that we have today, we have confidence that with 10 oral fluid samples, if they all test negative, the disease is going to be under 2%, if not 0. So it's really powerful tool. So family oral fluids, the good is also, as processing fluids, has a high diagnostic specificity. Sensitivity around 80% if you average all the scenarios. It's easier, more practical, and cheaper than individual pig blood serum, especially at that low prevalence scenario. I bet you don't want to sample a couple hundred piglets. And it's also good for antibody testing. All the diagnostic tests that have been developed for oral fluids, they would also work with family oral fluids because they are still oral fluids. The caution, we still need more data on a near zero prevalence, working on that. Not as simple as processing fluid, but still need to assess the due-to-wean piglet status, and to the best of our knowledge, the family fluids are the most practical way to do that, at least compared to individual pig sample. I'd like to acknowledge VI, Beringer Ingelheim, for supporting these studies. Also, excited to be working with the Iowa Pork Producer Association, that they will fund the follow-up with this study, which is to better understand family oral fluid sensitivity, specificity at low or near zero prevalence scenario. I'd like to thank again the ISU VDL team and the collaborators that have helped us to collect samples and provide, not only helping with samples, but also with ideas. Doctors Hans Roto, Peter Schneider, Clayton Johnson, Paul Yeski, Kate, Dion, Tara, Donovan, and others. All right, here I'm gonna talk about using of production data to screen herds for disease outbreaks in general. It's not specific to PRRS, but it would work for PRRS, especially if it's a wild type or virulent PRRS in a system. So again, this is number of aborts over time, and it's no big deal here. We've published that. It's not new that PRRS causes aborts, right? As it causes sows to go off feed, as it causes pre-weaning mortality, as it increases mummies and stillbirths. So what we are doing here is using this information. If you consistently collect that and throw that in a system and consistently evaluate those numbers using statistical methods, you could early detect signals of disease of PRRS outbreaks in the system. So we've done that with a preliminary study here in 2017, comparing what was the sensitivity to detect the spikes relative to what the system would report to the Morrison Swine Health Monitoring System. And results were promising. We were able to detect the disease outbreaks up to 4 weeks before the farm manager reported the status change for PRRS or the PRRS outbreak. And right now, it's already up and running. We have a website tool here housed in the Iowa State University. So with all the data security, confidentiality, and data encryption that the VDL and other ISU servers have, the portal offers a farm-specific username and password, where the users would enter their aborts, pre-weaning mortality, prenatal, so neonatal mortality and pre-weaning mortality, sows of feed, and they can do that again in their daily or weekly basis. And what the system does is the system runs in the background automatically an algorithm to detect if there is any signal, statistical significant signal, and it shoots an automated email notification to whoever that farm manager is, or whoever in that production system wants to receive data from that farm, with a chart, say, hey, here, you may have a problem. The number of aborts has spiked significantly. You may want to check that. So the system is up and running. So take homes for what we have discussed so far here is processing fluids may be it is a great tool for to screen farms for PRRS virus, because it's easy, it's cheap, it's consistent. So once it goes negative in farms that are undergoing elimination, if you really want to confirm the due-to-wean piglet status, you would jump and use family oral fluids in combination to processing fluids, right? And also combine production data with all this to be able to not only early detect the outbreaks between the sampling points, but also to understand now with time we understand that if you had a break, the expectation is that you are going to recover the number of the baseline in terms of number of aborts within X many weeks. You should have recovered the number of weaned piglets weaned by X many weeks, recover stillbirths and mummies by X many weeks. So if you know that you're infected, but now it's no big deal that you had, no surprise that you had a spike in aborts, but now you can ask yourself, all right, how big how severe was that break relative to the breaks I had in the past, or relative to other breaks that I see in my system. You have that potential to do that benchmarking as well. All right, I'll take 5 minutes here to about this VDL reporting project that we've been working. It's being funded by SHIC so far, and what it is about, it is about gathering data from the major veterinary diagnostic labs of this country: KSU, Minnesota, Iowa State, and South Dakota University, and we use aggregated data to better report and understand the patterns of disease detection over time, geographic space, sample type, age group, and other say filters or categories. It's being led by Giovanni, gentleman here. And here's just a snapshot here. I'm just gonna go quickly here over a few slides. You see here this is PRRS detection by PCR over time. So you see here, for example, number of cases over time, green, bluish, greenish here, representing negative cases tested negative by PCR, and red means positive over time here. You can filter. The good thing is that all this is available in a online dashboard. You'll have access to that if you want. And there are several filters that you may want to apply to address your specific questions. Here, for example, I selected only processing fluids from 2017 to now. Right, each bar here is a season, is a trimester, and you so there you are. You can see here also the percentage positive cases for PRRS, so percentage of cases testing positive for PRRS by PCR over time. You see here the seasonal pattern of PRRS over time. It's spiking here in proportion cases testing positive in winter months, and lower numbers here in the summer months every year. And we can not only see that PRRS is seasonal, no big deal, everybody knows that, but what we are starting to do is asking the data over time here. This shows the percentage of positive PRRS results over time from the year of 2015, 16, 17, and 18. We use historic data to forecast what's expected this time of the year. So the number of cases that are expected to test positive for PRRS based on what was observed on the previous years, using what we call the cyclic regression model. And basically what you see here is that number of cases being tested positive for PRRS in Iowa. If you filter only the state of Iowa, it's within the expected. So it's winter, it's still kind of, sorry, not winter anymore, but in winter here we did have spiking number of cases as expected. The next question is, all right, is that beyond expected, or is it what we saw last year? And based on this information here, it's within the expected. And then you could start asking more other type of questions, right? This here is the whole U.S., not only Iowa, but the whole U.S. And so PRRS detection over time, the whole U.S., you can see that it is beyond the expected based on historic data. And that's in agreement with what has been reported by the by the Morrison Swine Health monitoring program, where the PRRS incidence is around 30%, which is the highest level in the last six years. And you can see other stuff. I'm gonna jump quicker here, but RFLP over time, over regions too. You can go yourself and use the filters you want to answer your specific questions, right? Again, RFLP, comparing different periods of time or region. You can build your own maps with your own questions. So this is all free and available online. Same thing here for PED. Right now, PED, even though the detection level is beyond, this past winter increased and right now decreased. If you ask how is that relative to previous year, well, is exactly where it's predicted based on previous year's data. Story a little bit different for Delta coronavirus. There was a big spike or increase in number of cases testing positive for Delta coronavirus compared to previous years, and now is slowly returning to the baseline or expected levels. We also report disease detection by syndrome. Here you see the CNS over time, so 2016, 17, and 18. It's basically showing here that Streptococcus suis is the major agent associated with CNS disease. And it has been like this, at least here, since 2016. And also have the respiratory page showing what are the pathogens being detected over time in cases submitted for respiratory disease or cases with lungs and other respiratory tissues. PRRS, SIV, and PRRS and SIV together, they explain about 70% of cases, and after PRRS and SIV, it's a bit of everything else. So just one last story here before we conclude. What else can we use this diagnostic data for? Right? If you were monitoring number of TGE cases, and what were the results for samples submitted for TGE testing by PCR, you would see that most cases tested, there were some positives, some negatives here over time, right? It depended on the time of the year. So it ranged from 1% all the way to 27% cases testing positive for TGE over time. And after some point in time here, TGE disappeared, and there was a spike in number of cases here submitted for TGE cases, most of them testing negative. And guess what? This was 2013. This was a signal that something was wrong in the industry. It was PED. So people were submitting samples for TGE testing that was all negative for TGE because it was TGE. It's a good way too to use diagnostic data to understand, hey, there's something going on here on respiratory cases or enteric cases or any other type of cases. And again, this is all available online. If you go scan this or go to powerbi.com, use this username and password, it's going to be available, or just go to the SHIC webpage, swinehealth.org, and there will be a link. So again, we talked about different methods. Which one is the best? There is no best. There are different methods for different questions, and you just mix and match those to answer your question. The VDL data being more the mega trends kind of questions to understand what's going on in a big picture level, and then going to the sow farm using processing fluids to understand what's going on in that young piglet population. Family oral fluids for due to wean litters, automated SPC or production data to cover the gap between the weeks that you don't sample, or maybe you sample and you don't test for everything, right? But so if you see some indication that you have something going wrong in your production records, you may want to test for additional pathogens or do some additional disease testing. All right, so with that, thank you very much for time and attention, and looking forward to entertain any question if there's any, and if there's still time. Thank you.
We do have time for a couple of questions. Go ahead.
Two questions. When you move to your weekly pool processing fluid, keep them in the refrigerator every day, or freeze them, or what you do?
We froze them daily and then cool them, let the diagnostic lab do the cooling. So we froze each day separately, and the diagnostic lab cooled the thing.
Okay. And then before you went to your last section, you had a recap slide, and you were saying a weekly processing fluid plus 10 family oral fluids until negative 3 weeks in a row, or?
That was just a suggestion that processing fluids may be a good tool for screening, and there is no need to, at least I don't see, to be testing the DO2 when if you know that they are already positive. Yep. And then you start testing those, start testing, 10 is a good sample size to start with, and we'll do that on a weekly basis as well until you have some evidence to understand that the virus is really gone. Maybe 4 weeks in a row would be at least something to start with.
Write it down, Danny.
So I noticed on your family oral fluids, is there any difference between the PCR test be able to, or the prevalence of the virus to be in oral fluids compared to blood? Do you think that has anything to do with that sometimes oral fluids aren't taking it up, that maybe the virus is in the blood and not actually in the oral fluid?
It may be because when the pig is infected with PRRS, it's viremic right away within the next hours or so, and in the oral fluid it may take a day or two to be shed in the replicating the tonsils and be shed in the oral fluids. But there is the effect too that not all the pigs chew in the rope in that period of time that you hang the rope there 20-30 minutes. For some behavioral periods, even if you wait a whole hour or so, there are some piglets that they just don't contribute, they just don't chew on the rope. So there is this effect that different than processing fluids that all pigs do contribute because you get them and you castrate and you tail dog. The family fluid, the piglets still need to get up and contribute to the rope, to the testing.
Okay, let's thank Dr. Linhares one more time.